Welcome, everyone. This is a Snowpipe streaming session, and we will demonstrate and explain some of the fundamentals about streaming and then how we can help to reduce cost of streaming overall. I'm Parag Jain. I work as a principal architect in Field CT office at Snowflake, and I specialize in data engineering, and joined by Zin.
Hey everyone, I'm Zin. I'm the product manager for data ingestion at Snowflake, and I'm really honored to be here at Parag's session as a guest to talk a little bit about Snowpipe Streaming. But really, Parag is the man of the hour. He's part of our Field CTO team, so he's actively using our products that we built, that product and engineering build, and then he tells customers how to best leverage them. So this is his session on best practices and a demo on what he has done so far.
Thank you, Zin. And I have two kids. One is 6-year-old and another one is 1-year-old. So besides screaming, I have a passion in streaming. So during this session, what we will do is we will go over some fundamentals of streaming, and we will see how Snowpipe Streaming works. We'll apply that knowledge and put it together in an end-to-end pipeline. We'll see some transformations using dynamic table that will help you reduce your overall cost. And we will also see some of the common use cases. So let's jump onto it. Snowpipe Streaming is our latest innovation that helps you send low latency rows of data into Snowflake. It also helps you order your data as per your ingestion, and it helps you bring your data pipelines natively to Snowflake. You can do batch pipeline in Snowflake, and now you can do streaming pipeline as well in Snowflake. It comes with two flavors, I will say. One is the Snowflake Kafka connector, which comes built in now with the Snowpipe Streaming. And then there is a public API that we have released. It's an ingest API, which you can use. It's Java-based to build your own application, connect with the source, and then bring the data into Snowflake. Stream that rows data into Snowflake without any message broker in between. So no Kafka needed for the Snowpipe ingest API. But if you have a Kafka cluster, you can very well use the Kafka connector, and we support Snowpipe Streaming there. And to elaborate more on that, I will ask Zin, our special guest, to help us understand those two pieces.
Yeah, so we definitely built Snowpipe Streaming as a unified platform between batch and streaming and ingestion. With Snowpipe Streaming, you have low latency and low cost ingestion from your streaming applications on the web apps or databases directly into Snowflake without having to first let it into a stage. So this is made available with our ingest Java SDK. So that Java SDK is really what you use to build your applications. You can use it to build your own connectors. And Snowflake has built some of our own first-party connectors. What we started with is our Kafka connector. Kafka is built for streaming in the cloud, so it's cloud native. And it really makes sense for you to use Snowpipe Streaming with our Kafka connector to bring your messages from Kafka directly to Snowflake with low latency and low cost. But that doesn't mean we're stopping there at just Kafka. We've also built many other connectors. We have just recently introduced database connectors. So we have private preview for MySQL and Postgres, which are also using Snowpipe Streaming to have low latency change data capture from your transactional databases directly into Snowflake. And Snowpipe Streaming is currently in public preview, but we are going GA soon within the next month.
Yeah, and then Snowpipe Streaming is enabling new horizons for not just our customer, but also for our partners. They're using this ingest API without Kafka to pull data from source system and loading into Snowflake without any files in between. So where does it fit? Snowpipe Streaming and our Kafka connector with Snowpipe Streaming fits right at the start of ingestion. You can bring your data directly into Snowflake using these services. And then if you need any transformations, we still do have streams and tasks, but now we also have a declarative pipeline to build on top of your streaming data, and that's using dynamic table. So how it works, Kafka connector still supports Snowpipe, which is our primary way to ingest data into Snowflake using files. So you need a staging area somewhere, an object store or cloud storage to put your files using Kafka connector, and then it is loaded into Snowflake using Snowpipe. Now what we have done is we have innovated that pipeline, and now you can have streaming data flown into Snowflake without the need of any object store. So you have a Kafka connector that supports real-time streaming, pushes rows of data into Snowflake now. And we also have our bulk loading. So if you have files and you do not have Kafka connector, you can still load those files into Snowflake using the copy command. And that's what the base for Snowpipe anyways. Snowpipe uses the copy command to load that data into Snowflake.
Yeah, so this diagram really shows the unified batch and streaming architecture. You might have files from your partners, your vendors that come in as files on your staging, your object storage, and that gets brought in with either copy or Snowpipe continuously. Or you might have applications, web apps, database apps, or SaaS apps, and those can talk directly to Snowflake by patching files, having low latency, and all that can go into a single Snowflake table. And as long as you're within the Snowflake data cloud, you have all those privacy, security, and governance that you expect from Snowflake. And then you use the power of Snowflake compute to transform it to your refined tables.
This really concludes the whole nativity of Snowflake, where you can ingest and transform and then present this data to your end users. So what are some architectural benefits of using Snowpipe streaming? So traditionally, we have seen this architecture with Snowflake, where you have some sort of streaming services, some sort of messaging brokers, be it event hubs, be it MSK, be it a Kafka cluster, or be it any other streaming services. You will need to put those data files in an object store, and then Snowpipe will take that data and load it into Snowflake. We have also seen a batch pipeline where you use copy command to push that data from your OLTP system into Snowflake. So we have broken this trend, and now you can stream this data directly into Snowflake using Snowpipe streaming services. You can still keep your batch pipeline, but now you can keep both of them natively into Snowflake. So no ETL required, no external machines, external compute that you have to run. You don't have to run clusters of a Spark, or you don't have to run some other ETL services to push this data into Snowflake. You can directly connect source to Snowflake using the Snowpipe streaming services, and you're shipping rows of data. So this enables you to create a new real-time pipeline using Snowflake. If you look at box number 2, the data that you're shipping to Snowflake into a streaming table is readily queryable. You can query this data right from that table, even if the data is merging, keep ingested into this table. This will be an append-only table. You will insert rows of data as you go down in the pipeline, but you can still query that data live. So it really enables real-time analytics on top of your stream data. If you want a near real-time experience where you want to merge this data or join this data, or you have a CDC pipeline where you want to create an incremental pipeline, you can go ahead and use a dynamic table, which is again our latest innovation for building declarative pipeline. And the end result of dynamic table is a materialized table. This table can be used and exposed to your end users for faster data retrieval. How the Snowpipe streaming enables this is through the API, and then the API supports something called as client. So whenever you open up a session with the API, that becomes your client, and it opens up number of channels. These channels are mapped to a single table or multiple tables. One channel can be mapped to one table, but there can be multiple channels that you can open. So that enables you to ship hundreds of thousands of rows through these channels, millions of rows through these channels directly into Snowflake table. And to talk about more of this, I invite Zin to throw some light on client and table mapping.
Yeah, so definitely the Snowpipe streaming, you have a client. You can think of that as your application or your compute instance. And that's what Snowpipe streaming charges against. We charge against a single client on a per second usage basis. And then you can think of channels as threading for your computer. So you can open up as many channels as your application can handle. Let's say you have 100 topics, you have one client, you can open up 100 channels, a channel for each topic, and they can be writing to one or more Snowflake tables. So a channel offers exactly once guarantees. So you can use channel offsets to manage how you deliver your data and ensure exactly once ordered ingestion of your data.
So if you have, let's say, one partition or 10 partitions in a topic, you have like 10 channels?
That's right. You would have one client for your Kafka connector, and then you would have 10 channels for the different topics partitions that you might want to send your data to.
And let me see if I heard that right. This is per second billing.
Yep, this is per second billing at the client level. So we're not billing based on the number of channels that you have. It's really just the number of clients that you open.
So this if set up right, and there is very little to no configuration that you have to do. The channels that opens up with a client is automatic. It depends on if you're using Kafka connector, it depends on the number of partitions with the topic. And if you're using the SDK to build your own application without the message broker, then you can open as many channels as you like. Yeah. It depends on the strength of the virtual machine or the compute instance that you're using and deploying the SDK.
Yep. And then all you really have to manage is your client SDK. So that's the main interface between your clients, your data, and Snowflake. So the client SDK has rich error handling built in. So you can either say, if you run into an error, continue beyond that error, or return an error and abort. So we really manage, that's the only thing you have to manage, is sending the data and error handling on your side. And then once the data is committed to Snowflake, we handle all that offset management. So the data is securely stored on Snowflake, and then the channel offsets where you manage your exactly once ordering guarantees, we replicate that. So in case of any regional outages, you want to fail over from one region to another region, your data is replicated with Snowflake's replication. Your channel metadata is also replicated. So once you fail over, you can just continue where you left off and start replaying. So there's really little downtime, and Snowpipe Streaming is very good at handling any disaster recovery scenarios.
So the fault tolerance is built in.
Yep, it's fault tolerant built in, and it has all the benefits of Snowflake's governance built in as well.
All right, so let me show you guys a quick demo on how this all comes together to build an end-to-end pipeline. This will be a very short demo, but it will depict it'll open up a lot of possibilities about the usage of this particular feature within Snowflake. So I'm in Snowflake now. The streaming table that I'm going to stream data into is called custom dates local. And I'm going to stream 7.5 million reports into this table, and let's see how we can get there. First, let me just start my Kafka server. And let me just step back and talk about this a little bit here. What we have here is, so this table doesn't exist because I just deleted them. So what we have in Snowflake is about 7.5 billion customers' data, and it's keep on updating. Imagine you are a customer of an online store, and when you have some balance in your account, you go and purchase some item, and then that balance gets reduced, so you have a new record that needs to be shipped to your destination. So we will get all those flood and trickle cases of, let's say, 100,000 customers goes in and buys some product in an hour, and then another 100,000 goes and buy some product in another hour. So you get these flood of data, and then for some time there is no noise. So just to take care of these flood and trickle cases, you need a streaming service which will not break a bank, which will, even if it runs 24/7, it will only be on demand. So that's what Snowpipe Streaming is. It is truly on demand, only when you use it per second billing. So that all comes together to reduce your streaming cost. So let's see if our Kafka system is up. Yep. So we see now the Kafka is up, and it has started receiving this data, this customer data, from our source systems. So the topic that we're going to use today is customer update vlarge, and this has 5 partitions, as you can see here. All these partitions are building up with the rows of data that we are feeding from our source system. So now let's start our Kafka connector. This Kafka connector comes built in with Snowpipe Streaming. And while it's starting, let me go back to the settings. This is how the configuration looks like. And this is all you have to do. Take the Kafka connector. It's a JDBC jar file. You take that, you put it in your Kafka server or Kafka connector instance, and this is all you have to do. Few lines of settings. And if you're familiar with Kafka, apart from these 6 or 7 Snowflake settings, all of these comes with Kafka. You have to set it up with Kafka anyways. All right, and the switch between Snowpipe and Snowpipe Streaming is just this one property. If you're using a file-based data load from Kafka, you change it to Snowpipe. If you're using a row set based, meaning if you want to ship rows of data, you change it to Snowpipe Streaming. That's all. All right, so let's see if we have started receiving some records. All right, so we started, while I was talking, at 5-10 seconds, we already ingested 2 million records. And to see this, I built a quick dashboard with very simple queries between the source and target. I have 7.5 million records in my source, and I've already ingested about 1.5 million records. We are still 80% less than the source, and it's keep on adding new records to my Snowflake table. As you can see, it's bubbling up. While it's loading this data, I can go ahead and query this data on demand. So if user want to see real-time data, they can still query this, and I'm querying this stream data from this table. Right now, I'm checking the balance, the live balance of customers. If I want, I can see my top 10 customers as well. And then if I want, I can go ahead and pull all this information about my customer, what they're buying, how much they are spending, at what time they are spending, and what is my market segment, and so forth, so on. So this is based on my live stream data. So it is very important to know that sometimes we ask ourselves, hey, if I'm shipping this data into Snowflake, will it create a log? Will it not show me the right number of rows that I want to see? But that's not the case with a streaming table. You can still query the data on the fly while the data is streamed into this table. You can also build something like dynamic table on top of this. So if your end user who is connected to these dynamic tables, these tables will refresh at a cadence that you decide. So if you want to refresh these tables every minute, you can go ahead and refresh these tables automatically every minute. You just have to create them once, and it will refresh this data every minute connected to your streaming table. When and why it is important. So imagine if you have some reference data. Imagine you want to build a pipeline with the data that is only required for your business end user. You can take that SQL, put it in a dynamic table, and it will refresh automatically every hour. No pipelines needed, no airflow, nothing. It's all built natively into Snowflake. So what we are doing here is we are going to create a CDC pipeline. I have all this streaming data coming into my system. I want to manage the history of all the records, meaning at what time which customer purchased what, how the account balance from, let's say, $100,000 went to $50,000, where that $50,000 was spent. So the whole history is maintained. All that 7.5 million rows will be maintained in a dynamic table. And to do that, I'm going to create a dynamic table, which will have all the historical records. And this dynamic table will incrementally update as and when we receive the data from streaming table. Right, so let's see how many rows. All right, we are at the mark of 7.4 million. And if we go back, refresh this. Oh, there you go. So in 60 seconds, we ingested 7.5 million rows. And again, this is on my local laptop, so I have limitations. I only have 16 gigabyte of memory. Imagine doing this in a cloud server. Imagine doing this in a big cluster, Kafka cluster, and how you decide your throughput, basically. You decide how many partitions you want to ingest into Snowflake. Snowflake doesn't provide you any limit. You can also build, let's say, a dynamic table attached to another dynamic table. You can create a pipeline, chain pipeline. So I have my historical records, which should be now at 7.5 million. And this is what I was talking about. So when you create a dynamic table, you decide the lag, how sooner you want to refresh that table. And again, you can go from seconds to minutes to hours. As in when you run this dynamic table, it will build data incrementally. So today, if it is, at that moment, if it is 7.4 millions, and then after 10 seconds, if it is 7.5 million unit streaming table, it will only take that 100,000 records and build the data incrementally. It will not build the whole table again. So if I go back and check the count now, there you go. So it is now in sync. You can, like I said, you can connect two dynamic tables. So I have one dynamic table which relies on the another dynamic table. So let me build that as well. And what this is going to do is it's only going to show me the latest record of customers. So one row for each customer and the ending balance of that customer. It will not have any historical data. I can build that table. So I have a CDC table, which is connected to my streaming table and only doing incremental pipeline. And then I have my another dynamic table, which only contains the latest record, which has happened in the last 10 seconds or last 1 minute. Let's check the records. So this table only has close to 500,000 records. We have 500,000 customers. So live, let's push more data into this Kafka cluster. And I have a simulation where it pushes 250,000 rows, and let's see what happens. So we are now at sync. At this moment, we are at 7.5 million mark. What I'm going to do is I'm going to push 250,000 more rows into Kafka. And let's see what happens here. There you go. So now I have close to 7.8 million records in my pipeline. Still next that's record that I pushed to Kafka. Let's see if there you go. As soon as I push the data, it started building the pipeline again, and it's done. So this is the power of building pipelines natively into Snowflake. That's what you want to demo to you. Is if you build these pipelines natively in Snowflake, you do not need any ETL services. Plus, these pipelines will give you breadth of use cases that you probably haven't discovered in your organization. So go ahead and talk to your account team and ask them about Snowpipe Streaming and how it can help you increase in this digital age, increase presence in this digital age. What we have seen in this demo is summarized in this diagram, where we are connected directly to our source system or to a message broker, streaming this data into Snowflake and then building up a pipeline right inside Snowflake, which can be refreshed at any cadence, a minute, seconds, hour, continuously. We can do this with a message broker like Kafka or without message broker as well. So if you're doing without Kafka, you're going to save on the cost of that infrastructure. So it reduces cost. So what we have done is we have benchmarked with several tools. And what we have found is Snowpipe benefits in many ways. First of all, you can ship your data within seconds to Snowflake. You can directly stream your data through HTTPS or through your VPC. So you can ship your data to Snowflake through that. It has very high throughput. So you have gigabytes per second of ingestion rates that are supported through this. We have exactly one semantics like Zin mentioned. We also have fault tolerance built into the system. So we maintain the offset of rows at server side and at Snowflake side. So if there is any issue in this channel, we can start right off from where we left off. It has very minimum overhead. You have seen the configuration file. That's all you have to do. It gives you a chance to bring both batch pipeline and streaming pipeline natively into Snowflake.
Thanks, Parab, for showing that demo. That's exactly what most of our customers are using Snowpipe Streaming and dynamic tables for today. Is Kafka is a native messaging service, so we're seeing a lot of adoption from customers who have Kafka broker deployments, and our Kafka connector really makes it easy for them to bring their data from their Kafka source to Snowflake with low cost and low latency. And the benefits that we mentioned, Snowpipe Streaming is serverless on the Snowflake side. You don't have to manage any warehouses. You just send your data from your application. You can either use Kafka if you have it, or you don't have to use Kafka, and you can write your own applications and own connectors. And Snowflake manages all the security models, the governance, and the replication for you. And we've done this testing with gigabytes of throughput per second. We have customers that are sending trickle cases where it's 1 megabyte per second or less, and we have customers that are sending gigabytes per second through multiple channels, all from a single SDK. So it's really efficient for them to get that low cost. And again, the floor for Snowpipe Streaming is 1 second. So we set the medium latency as 5 seconds because that's the end-to-end. Customers are sometimes buffering their data before sending it to Snowflake, but Snowpipe Streaming supports latency as low as 1 second. So you really get your data in near real time.
And we haven't stopped there. We compared it with things like Spark Structure Streaming. Spark Structure Streaming is a micro batch. It is their attempt to reduce the cost, but it still has to run 24/7. It has to be hosted somewhere so that it can receive the continuous flow of data from Kafka. We have tested against that, and what we found is Snowpipe Streaming is 4 times cheaper with the same Kafka instance, with the same flow rate, with the same amount of data that you want to ship to Snowflake. We have also benchmarked a higher throughput. So if you send, let's say, 100 megabyte per second flow rate, you can actually ship 200 gigabytes of data in an hour to Snowflake. And that 1 hour will cost you only 1 credit. That's not the case with Spark Structure Streaming. So just to put things into perspective, if you're spending $1 million in Spark Structure Streaming, you're only going to spend $250K with Snowpipe Streaming. So that's the number, long, big numbers that we're talking about.
Yeah, and that bottom number of 1 credit per 200 gigabytes, we tested that with Kafka configurations between various throughputs. So I've written a blog if you want to look for best practices with data ingestion. We've gone over the configuration for our Kafka broker, our Kafka Connect server, and the amount of data that we're pushing from 1 megabyte per second to 100 megabytes per second and more. And we'll continue to publish those numbers so you can run your own benchmarking yourself and see how efficient and how low latency Snowpipe Streaming really is.
Yep. We didn't stop here. We compared it with Spark Structure Streaming, then we also wanted to test with our own API. So remember, Snowpipe Streaming comes with 2 pieces. One is the Kafka connector and the API. So we compared them together. We had a MySQL server instance where we connected Snowpipe Streaming with, and then started the flow to Snowflake, and that came out to the same amount of cost. But if you have Kafka in between, you are obviously paying for that infrastructure. So that cost just doubled because you're paying for Kafka. So we tested this as well with the similar rate, and the results come out on your screen, and we saved almost 2x if you're using an API directly. But if you don't have the engineering capacity, I'll suggest you to stick with your message broker. Keep using Kafka, and if you already have Kafka instances, if you already have some managed service for Kafka, keep using that. You can still use Snowpipe Streaming.
This is why we built the SDK and build first-party connectors. The SDK is really the tool that you use to build your applications. You can run it yourself. But if you have a Kafka deployment that you're already using, then the Kafka connector that we built makes it easy for you to take advantage of Snowpipe Streaming with minimal code. You just set it up and set the configurations, and it's sending data for you. And the same thing goes for our database connectors and our SaaS connectors that we're building. So really, it's a simplicity tool. You can either use you can build it yourself with our Java SDK for Snowpipe Streaming, or you can use our first-party connectors, or you can use connectors that our partners have built. So they've already integrated Snowpipe Streaming into our partner tools, so you can take advantage of that however you want. It's a really pick and choose, and Snowpipe Streaming is available for you to use for any workload that requires low latency and high throughput.
Awesome. And I just want to show you some more capabilities that we have built into. You really don't have to build your own observability dashboard. We are providing an observability dashboard built in for Snowpipe Streaming. You just select the Snowpipe Streaming table in your usage dashboard, and it shows you how much you're consuming. So this eliminates the uncertainty of how much I'm going to spend at the end of the day. You can test it out. You can create a pipeline. You can budget for the pipeline in the future. And this is the public-facing Git library, which has our ingest API. And all this is there in the presentation, and that will be shared with you after the summit. When we have recorded this session, so that this session will also be shared with you. But just to go over quickly on over this API, this is a Java-based API. It does have some implementation guidelines, but this is a open source, so you can use this and you can build your own application on top of this API, and it doesn't require any Kafka connector or Kafka servers. Using this and shamelessly promoting my own blog, I have created a blog for this. This will again be, the link for this blog will be provided to you as well. This is using, I've shipped 1 million rows from my MySQL server using that API without any Kafka server. So you can use this as an example as well. Very easy and simple configurations. And with this, include our demo. After the demo, you can go through these links. This has necessary links to understand more about Snowpipe Streaming, an example of Snowpipe Streaming as well. You will also have some links for credit consumption, but remember, it is per second. So even if you are using, in 10 hours, if you're using Snowpipe Streaming for only 1 hour, you're only paying for 1 hour. If you're using for 10 seconds, you're only paying 10 seconds.
Awesome. Thank you for the demo and showing how easy it is to build a Kafka connector or using the SDK directly. And just to reiterate, Snowpipe Streaming is GA soon. We are going to be GA within the next month. And Dynamic Tables is in public preview. So this is all available for you to use today without having to set up any additional parameters. You can go and test the limitations of your applications and bring your data into Snowflake as quickly as possible, have all the capabilities of Snowflake's governance and compute, and then go and get insights on your data for better business value